The Alexa Voice Service, AVS, enables device makers to integrate Alexa into their products through hardware and software development toolkits, bringing magical voice experiences and cloud-based intelligence to customers.
And welcome to week 2 of AlexaPi. My name is Caroline. Hopefully you joined me last week for doing the basic install of AlexaPi. Today we are hacking AlexaPi, and we're going through the advanced tutorials on the Alexa Voice Services tutorials page. Now, in order for this video to make sense, you would have had to complete the basic tutorial either according to the developer Alexa Voice Service tutorial or by watching my video from last week. If you haven't watched that, I'll link to it below and you can go ahead and complete that project first. This picks up exactly where we left off last time with Alexa Voice Service installed on our Raspberry Pi. And you will need all of the same materials from last week plus some additional materials. Number one, you'll need your Alexa Voice Service running on your Raspberry Pi from last week. You will need a microphone. You will need your speaker with a 3.5mm jack cable. You will need an HDMI cable. You will need a monitor. You will need a mouse and a keyboard here. Now, that was all from last week. Now, in this week's tutorial, if you want to go through the entire tutorial, you will need a gpio breakout kit. And I will link to it below, and it's got everything you need to do the rest of this tutorial. Full disclosure, did I buy a kit? Do I have that gpio breakout kit? No, I do not. I did improvise, and I'm doing the same project, but without that breakout. So I'll just show you right here what I have. I have the breadboard and I have the LEDs that they specified. They had a red LED and a blue LED. I've got the resistors, and I also have 3 jumper cables. They do specify you need jumper cables that are male to female jumper cables. You need 3 of those. Full disclosure, once again, did I have male to female jumper cables? No, I did not. I literally Google searched how to make a male to female jumper cable, jumper wire actually, not jumper cable, jumper wire, and there is actually a tutorial out there on how to make your own jumper wires. So I did that tutorial. I'll link to it below if you're interested in doing that. So I do highly recommend getting the kit, and it's only, when I looked at it, it was only $15 for everything, including the breadboard and the breakout pins, which I don't have, and the LEDs and the resistors and the right jumper wires and everything. So highly recommend that if you don't have anything. If I'm just going to use what I have right here with my breadboard. So I'll have that connected when we get to that section. I'll show you how I did it without the breakout board. So let's get started. And when we last left off, we were running our AlexaPi and testing out the different commands and getting comfortable with AlexaPi. So this picks up right where we left off. And then now I'm going to move on to the advanced Pi tutorials. And we'll start with indicating device state with sounds. It wants me to go to my voice service and resources. Alexa Voice Service, resources right here, and I can view the sound library. And Alexa Sound Library for AVS Zip, and I'm going to hit download. There we go. And we're going to download the zip file here. Next, we will go to our file manager right here. We'll go to downloads, and I am going to extract here. And here are my sounds. I'm going to double click on key sounds. I am looking for the sound medui wake sound.wav, and I'm going to save it into sounds. Medui wake sound.wav, and I'm going to try to move it into sounds right here. Okay, that did not work. Why did that not work? Well, I'll tell you right now because I've already been through this tutorial. I'm going to right click and I'm going to show you properties. And I'm going to look at permissions, and only the owner can change the content, and the owner is root, and I'm logged in as Pi. So this isn't going to work, and this is a little, in my opinion, a little defect in the instructions that were given, which is why it is great that I'm doing this tutorial today. I'm going to quit my Alexa voice service running. I'm going to stop that from running, and then I am going to run this command, sudo chown rpi home pi, and that changes the ownership to everything to pi. And I'm going to paste that command and run that right now. And where did I find that command? I found that command a few rows down from where we were just a second ago. So we were here a second ago, and then it wanted you to do a bunch of stuff that you can't do unless you run this command. So I just scrolled down and I found the command. All right, so let's go back to key sounds for AVS. There's my med UI, and I'm going to move that into sounds, and that should work now. Okay, it has been moved. There it is. It's been moved into sounds now. Alrighty. Now in the file manager, we're going to navigate to home pi, Alexa AVS device, SDK sample, and SRC. Okay, so where is that? That is right here. Sample app right here. SRC right here, and we're looking for UI manager.cpp right here, and I'm going to open with the voice for text editor over here. Sorry, I can't see the whole thing, but yeah, here's the text editor, and I will need to, near the top with the other include statements, I will need to include cstdlib library. So I'm going to right click copy, and I'm going to put that right here. Right click paste, and then I will need to find the right UX state to put the wake sound to enable this UI. Okay, so I'm looking for, it shows me, it's going to show me right here. I'm going to copy system, and I'm going to paste it in case dialog listening. So when it's listening, I want to have it play this sound. And here we go, UI manager print state, and when it is listening, I want to add a new command, paste, which is system play home pi sounds med UI wave, and then I'm going to hit save right here, and then it says to sudo chown, which I've already done, and now I can go back to my terminal, and I'm going to cd into the sample app here on my terminal, paste, enter, and then I'm going to sudo make, and that will run another make of this Alexa voice service. Okay, we had a successful sudo make here. Now we've got to cd back into our home directory, home pi directory. Then we want to sudo bash start sample again, and we should be starting our Alexa voice service again. Now let's test out what we just added to our code. Alexa, what is 2 plus 2?
2 plus 2 equals 4.
And did you hear that beep right after I said the wake word? That's what we added. That was that wave file. So now we have an indication when she's listening. So when we say her name, Alexa, you hear a little beep so that you know that she's listening to you. And that's what we've added. So now you can take the other wave files and add it in where you see fit and kind of customize it or hack your AlexaPi. Next, I'm going to go a little bit off script here and continue hacking this, and we're going to add a sound so that we know that in preparation for the auto boot next week, I'm going to add a sound so that I know when she's booted up, so that when I turn it on without the monitor, I know when she's ready to go. That was pretty cool. I've stopped the AVS service for now, and we can repeat this process so that we can get sounds the way we want the sounds in our personal AlexaPi. Let's see. So I am now going to github.com/Caroline Dunn. That's my name. And I'm going to download the hello. So that way when I boot her up, she'll say hello. I think that'll be a nice little touch. That is my opinion. You don't have to follow this part of the tutorial, but I think that'd be fun. So I clicked on, so this is the old Alexa RPI auto start here. I will update that for you, but there is this nice little hello wave file. I'm going to click on it, and then it will give me the option to download that file. Right click on the sound file and click Save As. And let's see, where should I download this to? Oh, I guess I'll download it to Downloads for now. I'm going to hit Enter. And there it goes. It's been downloaded to Downloads. And I'm going to open a new file manager right here. And we're going to go to Downloads. And I should see my hello right here. And I'm going to move that over into Sounds again. So we're following the same process. If this looks familiar, here it is. So now I've got the hello. And then we'll go through the same steps again. So we're going back to our src folder UI manager.cpp. I'll move this over so that you can see this a little bit better, hopefully. And I'm going to select the second text editor. I've right-clicked and then hit text editor. It comes right up. Let's see. So we've got Alexa is currently idle. We've got a sound for when it's listening. Let's add this. Okay, I'm going to put it under connecting, and I'm going to paste that right there. So if it's connecting, I want to play a sound. So it should say connecting, and it should play a sound. And that sound is going to be the hello. So I'm going to replace med UI with hello, and I'm going to save that. Then I'm going to go through the same process here. And I can just hit my up arrow just to get it CD home into the sample app, and then I want to sudo make. We'll go through that process again, and then we will run the start sample again. Okay, and let's open up the sample app. So I'm going to sudo back home to pi, sudo bash start sample.sh.
Hello.
Oh, did you hear that? And now we know that it has started, so I'll quit that. And let's go back to the camera. And we're back, and now we're going to test out if she says hello when the application starts. So we will sudo bash start sample.
Hello.
And she has started. And now I know that I can say, Alexa, what is 2 plus 3?
2 plus 3 equals 5.
We've got our sounds hacked now, and we're going to move on to the next step, which is priorities. Now that we have customized our sounds, let's modify the focus manager and just keep on moving along on these advanced Pi tutorials. So first we'll indicate 2 competing capability agents here. I need to run my sudo bash start sample.
Hello.
Okay, and I know it's started, so I'm going to say, Alexa, set a timer for 20 seconds.
20 seconds, starting now.
Alexa, sing me a song.
The tents go up, the sun goes down, campfire heats up, we gather round. We watch the fireflies dancing in the...
Alexa, stop.
moonlight tonight. Here we
Alexa, stop. So the point that they're trying to make here is that the song was interrupted, or the song completely stopped because of the timer. What they're going to demonstrate for us, or what we're going to demonstrate in this portion of the tutorial, is we're going to have the music keep on playing and then the notification, the timer go off above it. So you'll still continue to listen to the music. And that is the purpose of this tutorial here. Let's move on. In my file manager, I am going to Alexa AVS SDK, and then AVS Common right here, and then SDK interfaces right here, include AVS Common K interfaces, and I should see Focus Manager Interface.h. So I'm going to find that file, and I'll right click and I will select text editor, and I will see the different priorities. So here, we've got dialogue 100, alerts 200, communications 250, content 300, and visual in my channel priority. And I'll notice that content channel priority is currently set to 300. Sure enough, content channel priority is now set to 300. So let's make it a higher priority than our 20-second timer by changing the 300 to 199. And I'll hit save, and then I need to rebuild my sample app. So I'm going to cd into the sample app again, and I'm going to sudo make again. And we're back here. We have just finished doing our sudo make, and let's go back and restart our start sample here. Now the next instruction here, I don't believe this is correct, but we're gonna try it anyway. I think it's just cd home pi, which we've been doing this whole time, but just to give it a shot. Let's see what happens. Copy paste. No such directory. Well, that's true. Let's see. So let's go back to cd home pi, and then let's start our sample again.
Hello.
Okay, it says hello. So now we're going to do the same process as we did before. We're going to say, Alexa, set timer for 20 seconds.
20 seconds, starting now.
Alexa, sing me a song.
Up in the hills, the campfire roars. Graham crackers snap in 2s, 3s, and smash them together.
Alexa, stop. And if you heard it closely this time, now the song kept on playing, but we could faintly hear the alarm going off in the background. So that is how you change channel priority, and you can go through the code. So go through the focus manager interface.h, and then you can change around all the priorities and really hack this AVS service in the way of your preference. And then of course you'll have to do another sudo make and then start the sample again. So I'm going to quit this for now, and we're going to move on to the last part of our advanced tutorial today, which is indicating device state with LEDs. Now, honestly, this is my favorite part of the entire project, the LEDs. And so I'm going to show you how to hook up the LEDs right now. I don't have the GPIO breakout board, but I do have a breadboard, and I did have the other components. So how did I know how to hook it up if I didn't have the GPIO breakout? No problem. All I did was look up, and you'll see this on the left side of my screen. I looked up the pinout for the Raspberry Pi. And the pins, this is upside down unfortunately, but the pins start with number 1 and number 2 on this end, and then count up from here. And so I can follow the pin out, and then I looked at the diagram on the right, which is how I'm supposed to hook it up if I did have a GPIO board. Now, looking at the GPIO board, I needed to connect ground to ground on the 5-volt side, and then I needed to connect the red to GPIO pin number 17, or GPIO 17, and I need to connect the blue to GPIO 18. So let's connect the ground first. The ground wire is where the short end of the LEDs go into this railing right here. So they're connected this way, 5 in a row, and then the power and the ground are connected up and down. So this is the negative rail. How do I know that I put my pins in the negative rail? The shorter pin is the negative, the longer pin is the positive. So I connected the positive to the resistor, and I connected the negative to the ground rail here. So I did that for both of them. Then I put in my resistors. I've connected the positive of the LED to one end of the resistor. On the other end of the resistor, I've connected my jumper wire here. So let's do the ground wire first, according to the pinout, which is the 3rd pin down on the right hand side. Let's put that in right now. The way I'm counting it, it is upside down. So it's 1, 2, 3 from the bottom, which is really the top for me. All right, there we go. And then the red pin goes into GPIO 17, which is the 6th pin down on the left hand side. 1, 2, 3, 4, 5, 6. And same thing for the blue, it is GPIO 18, and it is the 6th pin down on the right-hand side. And that should get us correctly wired up for the LED portion of this hacking AlexaPi project. And now we're ready to start our final advanced tutorial for this lesson today, and it's called Indicating Device State with LEDs. And let's see, so here we go. This is the GPIO breakout bundle, and it's about $15 last time I looked, and it includes everything you see here, and it has all the parts you need in addition to everything you've already set up for this AVS lesson here. I've gone through how to hook this up already, And let's start modifying the AVS Device SDK. Now, in our File Explorer, we're going to AVS Device SDK sample app right here, and then SRC. So let's double click on that, and then we're going to open main.cpp, and I'm going to right click and then select the text editor, and we're going to include wiring pi.h, and I'm going to add that right here, and right click paste. Next, I'm going to set up the wiring pi setup and under the init main function here. And here is initialize main right here. I'm going to enter, and then I'm going to right click and paste our new code right here, wiring pi setup, and I'm going to hit save. And still in the same folder, I am now going to open the UI manager.cpp. So I'm going to hit text editor, right click text editor, and I need to include wiring pi.h, copy right here, include wiring pi.h, and then I'm going to look for UI manager microphone off, and I'm going to add digital right 0 high. So that's my red LED. I'm going to turn it on high when the microphone is off, is what I'm looking for here. So let's scroll down and see when the microphone is turned off. Right here, microphone is off, and I'm going to hit enter and tab, and I'm going to right click and paste digital right equals high. And then when the microphone is on, need to look for that code. I'm going to digital right 0 high, and I'm going to change that to low. So if the microphone is off, the red LED will be off, and that is indicated by low. Okay, I'm going to go ahead and hit save before we go any further. And then I want to initialize the LEDs so that at startup it's always off. So I'm looking for print welcome screen here, print welcome screen, and I want to have digital right equals low, or digital right low, copy, welcome screen. And I'm going to write that twice just to make sure everything is off when I start it. So I'm going to have a 0 for the red. 0 pin means the red LED, the 1 equals the blue LED. So I'm going to have both of them low when we start this. Now let's do the blue LED here. So we're looking for listening, and when it's idle, I want it to digital right low. And I'm going to select 1. That's my blue LED. And then when I'm listening, I want to have digital right high. So when it's listening, I want my blue LED to be on, and then when it's thinking, I want my blue LED off again. So I've got low if it's idle, high if it's listening, and then low. And that is for output 1, which is the blue LED. All right, excellent. So I'll hit save. I will need to change the CMake file in the project wiring pi library. And so let's go to SRC again. And I should see a CMake list, and I'm going to open that in the text editor. I need to add target link sample app, so I'm going to copy paste this code into the last line. Enter, enter, and I'm going to right click and paste target link libraries sample app wiring pi, and I'm going to hit save. And I'm going to close this editor here, and I need to rebuild my sample app again. CD into sample app. I'm going to sudo make. You kind of get the idea now. And we are back. So we have done our sudo make here, and next we're going back to home pi. And if you ever see me scroll through the old commands, I'm just hitting the up arrow. I am going to sudo bash setup. Config.txt is the parameter. We are doing a sudo bash setup, so we're going to reset up the entire thing. Here I need to type in agree again, and we're going to run through the entire setup again. Wow, that was quick. And then sudo cd home pi, and then let's sudo bash the start sample here. And now let's see how our LEDs work here. I'm going to say, Alexa, the blue light, what is 2 plus 3?
2 plus 3 equals 5.
All right, and so the blue light lights up when she's listening. So now we know when she's listening. Now, where did they get that from? And I'm going to say, Alexa, and that is where this blue LED comes from. It's making it more like your Echo device. Now I'm going to hit M for mute or microphone off, and the red LED comes on, and then I'm going to turn it off. So let's turn it back on again. The red LED is on. Where did we get that from? Well, when we mute our Echo device, the red light comes on. So that's a little bit packing the Alexa just so that you can have some similarities. Now we're going to change this up a little bit. In preparation for next week's tutorial on auto boot, we're not going to be able to mute this anymore. That's something we're going to give up, is all those keyboard commands if you want to do the auto boot version, or a version of that anyway. So I'm going to change it where it's blue when it's listening and it's red when it's talking. And that's pretty easy to change, and I'm going to screenshot that right now for you. And here we go. I'm going to do a Q for quit, and I'm going to stop the AVS service now. And we're going to really repeat what we just did previously in one file, not everything. Just in the UIManager.cpp that was in AVS device SDK, sample app, SRC, and here's our UI Manager. I'm going to right click and select text editor. In the last step is we said, okay, if it's idle, the blue will be low. If it's listening, blue will be high. And if it's thinking, blue will be low. So now let's see. Let's do speaking. Now, so first I'm gonna set the state. So digital right, 0 to low. So now in idle, both the red and the blue LEDs are off or low. And then when it is speaking, I would like for the red LED to be high. So I'm going to select this, copy, and then paste right here. And I'm going to change this to high. High, so I need to change that to 0. Red will be high when she's speaking, and then blue will be high when she's listening. Okay, and I'm just going to make that one change, and that way I can see the red and the blues change about. I'm going to hit save. I'm going to close that, and I'm going to have to rerun the make here. So I'm doing my up arrow so I can get into the right folder. Then I'm going to go into sudo make, and you know the drill on that. And we have done our sudo make, and now we're going to home pi, and we're going to do sudo bash setup.sh with the config, and I'm going to type in agree again. And now I'm going to start the start sample again. Enter.
Hello.
Now I have hacked the AlexaPi so that the red light comes on when it's muted, and it also comes on when it's talking, and the blue light, it turns on when it's listening. Okay, let's check that out right now. So I'm going to unmute it, and I'm going to say, Alexa, what is 2 plus 4?
2 plus 4 equals 6.
And you see the red light comes on when she's talking. Alexa, tell me a joke.
Why did the pencil stink?
Adding LEDs to our project. So we've done 3 things today. We have added LEDs, we have changed the priorities, and we have added sounds to our AVS app today. So anyway, so that concludes today's tutorial. Please join me next week. We will continue this by doing everybody's favorite tutorial, auto boot, where it will automatically go into the AVS service, I'm going to say, or AlexaPi service when you turn on your Raspberry Pi. Join me again next week for that tutorial. Thanks for watching. Please subscribe. Bye.